Welcome to the intersection of technology, cybersecurity, and society. Welcome to ITSP Magazine. You're listening to a new episode of Stories from Space podcast, where your host, Matthew Williams, examines the history of human spaceflight, the breakthroughs that revolutionized our understanding of the universe and our place in it, and the brave individuals who work tirelessly to advance the frontiers of our understanding. Knowledge is power, now more than ever.
The authors acknowledge that this podcast was recorded on the traditional, unceded lands of the Lekwungen peoples. In 1950, Italian-American physicist Enrico Fermi sat down to lunch with some of his colleagues at the Los Alamos National Laboratory. Fermi had worked there 5 years prior as part of the Manhattan Project. According to various accounts, the conversation turned to the subject of aliens and the recent spate of UFO sightings. As they sat down to eat, the conversation had turned onto other topics. But according to his colleagues, Fermi asked, out of nowhere, "Where is everybody?" His colleagues laughed because they understood exactly what he meant. In short, Fermi was addressing a conundrum that continues to plague astronomers, cosmologists, and astrobiologists, and all those who are engaged in the search for extraterrestrial intelligence, known by the acronym SETI. Given that the universe is so big, and that life has had so much time to evolve in other star systems and other galaxies, shouldn't we have heard from them by now? Shouldn't Earth have been visited by an extraterrestrial intelligence with advanced technology? This became the basis of what is known as the Fermi paradox, a question that has remained unresolved to this day, and quite frankly, may never be resolved. In order to do so, we must finally answer the question: is humanity alone in the universe? I'm Matt Williams, and this is Stories from Space. Hello, and welcome to Stories from Space. And today, we will be addressing that age-old question, is humanity alone in the universe? Or rather, we'll be looking at how the Fermi paradox has framed that question. So to give you a breakdown, the Fermi paradox, as it's come to be framed, given the age of the universe, given the sheer number of stars, galaxies, planets in our universe, and the fact that the ingredients for life appear to be in abundance everywhere we look, it basically states that humanity should have found evidence of extraterrestrial life by now, or been visited by an extraterrestrial intelligence by now, and the fact that we haven't, well, it demands an explanation. Now, to give you a little bit more background on the conversation itself, for many people, the idea that Fermi had this little sit down with his friends and they began debating the existence of extraterrestrial intelligence and why we haven't heard from them yet and when we might expect it, it was thought to be apocryphal. That is to say, it was right up there with Newton's apple or George Washington and the cherry tree or Archimedes and the Eureka incident. But in fact, this conversation has actually been confirmed. It's been documented because in 1985, Dr. Eric Jones, who worked at the Los Alamos Laboratory for 30 years, he decided to track down the legend by finding the people who were part of this conversation. As he would later write in the NASA Apollo Lunar Surface Journal, which was a regular publication that he created and oversaw on behalf of NASA, he said that thanks to the excellent memory of Hans Mark, who had heard a retelling at the Los Alamos in the early 1950s, we now know that Fermi did make the remark during a lunchtime conversation about 1950. His companions were Emil Konopinski, Edward Teller, and Herbert York. All three have provided accounts of the incident. And so these individuals who he mentioned, they were all Enrico Fermi's friends and colleagues, and they all went on after the Manhattan Project to enjoy prominent careers as physicists. But yeah, whereas Enrico Fermi died just a few years after the story took place, these men lived well into the 1980s and were therefore able to relate what they remembered of it. And of course, as with all stories that happened decades ago, and given the nature of human memory, there were various differences in their accounts as to the details of the conversation, but the central parts of the story there, the central themes, they all confirmed that they happened. For one, they had met up together to have lunch. They were taking a stroll. As they walked, they spoke of UFOs, which had become a very popular subject at the time. They talked about flying saucers, and even an editorial cartoon in the New York Times, which jokingly suggested that the recent spate of disappearing garbage cans or dumpsters might be due to aliens. In any case, the accounts also agreed that it was as they were sitting down to lunch, the conversation had moved on, but then, apropos of nothing, Fermi blurted out, "So where is everybody?" And they all understood what he meant. And then Fermi followed that up by asking his colleagues there, "So what do you think? How long would it take for aliens to develop advanced propulsion technology and, find their way to the solar system from a distant part of the galaxy?" This prompted all kinds of scrawlings and mathematics being done on napkins. And what Fermi ultimately determined was that, well, given the parameters we're using, given the assumptions that we are admittedly making, Earth should have been visited several times by now. But surprisingly, the way the Fermi paradox has come to be known, how it's come to be argued, how the whole question of is humanity alone in the universe, in this case, it wasn't framed by Fermi himself or any thoughts he had on the subject. Michael Hart, it started with him. He was a astrophysicist and white nationalist and separationist who in 1975 raised this popular legend about Fermi and the question he asked during this lunchtime conversation. In fact, the dubious honor for that goes to two scientists named Michael Hart and Frank Tipler. And between the two of them, they crafted what's come to be known as the Hart-Tipler conjecture, which essentially states that given, just how vast the universe is and how the assumed likelihood of intelligent life out there, Earth should have been visited several times by now by an extraterrestrial intelligence of one kind or another. The fact that it hasn't is proof that humanity is alone. Now that's the Cliff Notes version. To give you some more detail on that, it was in 1975 that Michael Hart first proposed such an argument. He was an astronomer and also, interestingly enough, a white supremacist and separatist. And in my humble opinion, his political and racial views, they can be seen in his research, in that it was loaded with some very open and shut thinking, very black and white, very laden with assumptions. And as he said in his 1975 paper, An Explanation for the Absence of Extraterrestrials on Earth, it all came down to what he called Fact A, in which he said, if there were intelligent beings elsewhere in our galaxy, then they would have eventually have achieved space travel and would have explored and colonized the galaxy, as we have explored and colonized the Earth. However, Fact A, they are not here, therefore they do not exist. Like I said, a very narrow-minded approach. And furthermore, he came up with estimates that were based on some very presumptuous math. So he calculated that at a relatively modest velocity of 1/10 the speed of light for a highly advanced civilization, a single species would have been able to expand and colonize our entire galaxy in 650,000 to 2 million years, which would have left so much in the way of just visible indications and so forth that we would not have failed to notice, and that this would most likely have resulted in them establishing a presence here on Earth. Now, his arguments would be expanded on and refined by Frank Tipler in 1980, and with a series of papers that he would publish over the next few years. And it started with a paper very unambiguously titled, "Extraterrestrial Intelligent Beings Do Not Exist." So he presented a much more sophisticated argument, but it still came down to the same very basic logic. So he said, in addition to a rocket technology capable to our own, it seems likely that a species engaging in interstellar communication would possess a fairly sophisticated computer technology. I shall therefore assume that such a species will eventually develop a self-replicating universal constructor with intelligence comparable to the human level. As such, a machine combined with present-day rocketry technology would make it possible to explore and/or colonize the galaxy in less than 300 million years. Now, what he's referring to in terms of these self-replicating robots was an idea that had been suggested previously, several decades previously, by John von Neumann, the famous computer scientist and the man who essentially spearheaded the field of nanotechnological studies. In any case, this idea for self-replicating machines eventually was adopted by astrophysicists and members of the SETI community. They said that this would be the best way to explore space, and if we can think about this, we can conceive this now, we have to assume that an extraterrestrial species, having had a jump start on humanity, having emerged sooner in our universe, would have done it already. So the fact that we haven't seen any self-replicating probes out there is a classic argument of people who believe in the Hart-Tipler conjecture. However, Carl Sagan was having none of this, and in 1983, he and his fellow physicist and colleague William Newman, they came together to write a rebuttal essay, and they called it the Solipsist Approach to Extraterrestrial Intelligence. And it was nicknamed Sagan's Response because the paper was written directly in response to what they had to say. In addition to first explaining how, since the age of Copernicus, every scientific truth we've ever found has confirmed that humanity is not special or unique. That's the Copernican principle. Yeah, so therefore assuming that humanity is alone in the universe because there's no evidence to the contrary is very provincially minded. And as he wrote, seeking, in effect, a universal principle to explain the apparent absence of extraterrestrial beings on Earth, Tipler contends that if extraterrestrial beings exist, their manifestations will be obvious. Conversely, since there's no evidence of their presence, they do not exist. And his next words have become a famous quote, "But absence of evidence is not evidence of absence," that Hart and Tipler had employed. So first off, in addition to just the philosophical underpinnings, Sagan and Newman, they took a scalpel to all of the assumptions that were contained in both Hart and Tipler's papers. And so, for example, Sagan looked at, the 300 million year estimate. That's based on a replication rate of 10,000 probes a year, traveling at 1% the speed of light. But even at that relatively modest value, probes of that nature, they would have converted the entire mass of the galaxy into von Neumann machines within a few million years. So it is not a logical argument that an extraterrestrial intelligence would rely on probes that would endlessly self-replicate to explore, because it would have been suicide. Furthermore, Hart's assumption, it all came down to the idea that an intelligent species would spread from one star to the next at a constant rate of 10% the speed of light, taking no time at all to settle new worlds, actually settling in before sending out more ships, which is, again, ridiculous. And they also cited a previous paper Sagan and Newman had written that countered this kind of thinking, and the paper was released in 1981. It was called Galactic Civilizations, Popular Dynamics and Interstellar Diffusion. And what they said here was that given the time and energy it takes to travel between stars, alien signals and probes could not be expected to operate based on some sort of simplistic timetable, that in fact the process for reaching from one end of the galaxy to the other through gradual colonization and spreading, that would take far, far longer than any assumptions made by Hart and Tipler. Having said all that, there's still the remaining question. Why haven't we heard from any extraterrestrial species? And Sagan and Newman, they offered many, many possible explanations as to why that is, all of which really came down to, we just don't know. We can assume nothing. We not only do we have an absence of evidence, we have a complete lack of a frame of reference. The only intelligent species humanity knows, that is aware of, is itself. And our understanding of what constitutes intelligence is rather incomplete. In fact, Earth has many intelligent species on it, but we tend to think of intelligence in a very narrow way. Also, we've barely scratched the surface when it comes to exploration and the search for extraterrestrial intelligence. Our solar system alone, it consists of so many objects, many of which are actually interstellar in origin, that were captured by its gravity. The asteroid belt and the Kuiper belt alone, we're talking trillions of objects, and to date we have observed only 4 in the Kuiper belt, and I believe several thousand in the main asteroid belt. But again, scratching the surface. We have sent crewed missions only to the moon. That's the only celestial body that we've sent astronauts to beyond low Earth orbit. We have looked far afield with our space telescopes, but we don't even know what we're looking for. And in terms of listening for communications, we don't know what a extraterrestrial transmission would look like. So the real resolution to this question, I would say, is that given the state of our ignorance, given how little we know, no conclusions can be arrived at either way. But theories and conjecturing about what form extraterrestrial intelligence and its technology and also its biology and the state of its biosphere, the type of planet that gave rise to it, those are very useful in the meantime because they help establish ideas and constraints on what we should be looking for. Then we have, sort of a template to compare our observations to. And that's really what we've been doing for the past 60 years since the first SETI experiments began. And in the coming years, they are destined to get a whole lot more advanced and exciting with next generation telescopes, and that includes everything from optical telescopes and infrared telescopes like the James Webb, and also radio antennas like the Square Kilometer Array. Suffice it to say, there is so much left to learn, so many places that we need to look closer at. And another really exciting thing about next generation telescopes is that they're going to advance the field of exoplanet studies just exponentially. We're finally going to be able to observe exoplanets directly. And given how far away they are, they're going to look like a little more than little dots of light. But that really doesn't matter because that light that we're seeing is light being reflected directly off of a planet's surface and atmosphere. And using spectrometers, the scientific community is going to be able to determine what the composition of those atmospheres is, and maybe even detect signs of photosynthesis or biological processes on the surface of the planet itself. So in just a few years, the exoplanet catalog, it's going to go from 5,000 confirmed planets and a little over 8,000 candidates that are awaiting confirmation to several tens of thousands. And rather than simply classifying planets as potentially habitable, we'll be able to say that, yes, by Earth standards, they're definitely habitable. And beyond that, these direct imaging studies will also allow us to look for obvious signs of technological activity, like lights on the surface or huge bands of satellites in orbit. So the possibilities are really, really exciting. But the bottom line is, we don't know yet. We don't know. But the bottom line is, when confronted with the age-old question, are we alone in the universe? Why haven't we found evidence of intelligent life yet? The answer to both is a resounding, we don't know. We haven't been looking nearly long enough, or nearly far enough, or deep enough, or in nearly enough detail to be able to say for certain whether evidence even exists. But that's about to change. And it won't happen all at once, of course. It's going to take many, many, many generations before we can confirm anything. But we will have a much better idea at the very least. And I can think of no better way to sign off than to mention the very quotable quote by famed and legendary science fiction author and scientist Arthur C. Clarke, who said that 2 possibilities exist. Either we are alone in the universe, or we are not. Both are equally terrifying. I'm Matt Williams, and this has been Stories from Space.
We hope you enjoyed this episode of Stories from Space podcast with Matthew Williams. If you learned something new and this podcast made you think, then share itspmagazine.com with your friends, family, and colleagues. If you represent a company and wish to associate your brand with our conversations, sponsor one or more of our podcast channels. We hope you will come back for more stories and follow us on our journey. You can always find us at the intersection of technology, cybersecurity, and society.